Hey coders, welcome back. So we again going to solve some random online assessment question from the Leetcode. If you don't know, there is a assessment section in the Leetcode, and basically they provide these three ones: online assessment, phone interview, and on-site interview. And you can choose any set, right? And the questions are going to be generated randomly. And it also says like here you can see its questions are from the real company, right? So you are practicing a good questions, right? So yeah, today I'm also going to attempt one of it. So I have multiple videos if you don't know about this assessment, so you can check them out. So today I'm planning to go through this one on-site interview. So there will be four questions, right? So one is easy, two will be medium, and one will be hard, and the time for completion is 2 hours and you cannot pause the timer and all, right? So let's start. Let's see. So you see we have only three questions. Okay, no problem. Sometimes it comes three questions, sometimes two questions. So yeah, so let's see the first question what it says. So it says like you are given a string something jewels representing the type of stones that are jewels and stones representing the stones you have. Each character in a stone is a type of a stone you have. You want to know how many of the stones you have are also jewels. Letters are case sensitive, so A will not is considered different than capital A. Okay, it's pretty weird a definition. Let's try to understand from example maybe. They have not explained anything. Okay, so we have jewels, some string, and then here we have some stones, A, and B, B. So what it is saying, you are given a string jewels and representing the type of stones that types of stone that are jewels and stones representing the stones you have. So each character in the stone is a type of stone you have, right? So we have small a, capital A, and small b. You want to know how many of the stones you have are also jewels. Okay, okay. So you see, we have this is small a, right? And this capital A is jewel, right? So here, how many of them are basically jewels, right? So we have this is small a one time, capital A one time, capital A one time. So answer will be three, right? Because these B's are not present basically in this string. So I don't think you need a lot here. Yeah, you can simply store it somewhere, the jewels character, and then iterate over these elements and check whether this is already present in jewels or not, right? So, what will be the idea? The idea will be something like this. I can create a set of characters. Let me increase my brightness little bit. Okay. We're gonna create a set of character, new headset, and then I will call this as a J. I will call this as a S, and then I'm gonna iterate over each character of a J, right? So J dot to char array, I can say. Instead of writing for loop and iterating and extracting the characters, you can use enhance for loop, right? Set dot add ch, right? Now we just need to iterate over each of the stone and then check whether this is already present in our set or not. So if that dot contains ch, good, we're gonna increase the count and then we're gonna return the count. Let's create this count also. So yeah, I think pretty straightforward. Let's try submitting it, running it. Okay, we have an error. Okay, I have a spelling mistake here. Count. Do we have any other error? No. Okay. Okay, I'm getting 3. Let's try submitting it. Yeah, I think it's pretty easy. Nothing fancy here. So let's move to the next question. Okay, so it's a linked list question. What it says. So given a head of a linked list, remove the nth node from the end of the list and return its head. Okay, so I just wanted to give you one quick, I would say trick. Whenever you get asked to do something on a linked list from the end, you can basically convert that question into remove something, start from the end, right? So let's say if I'm being told like find the kth node from the end, right? So like if I have to find like k represent, we have to find kth node from end. This is same than saying find uh, n minus k plus 1th node from start. So this is a small trick that you can use for these kinds of questions, right? And the rest of it, I think we just need to update the pointer. So for example, here in the list, if you see, if I'm able to reach 4, right, and I just have the access to its previous, I just need to do previous dot next is equals to previous dot next dot next. Simple, right? So if I just change this pointer, the pointer from 3 to 4 to 3 to 5, this is it. So here it says we have the size is gonna be 30, note that value is gonna be this, and the good part is n is always going to be less than equals to the total number of nodes, right? So what's the first step? We're gonna find the size of the linked list, right? So I will name it as a k, not n. So let's find its size of I will call that as a n. I will create a dummy variable current that will point to the head, right? We are simply going to iterate over the linked list until it gets null, and then we are going to increment our n one by one to count basically how many nodes are there. So how can you do that? You can simply say while current is not equals to null means there is a one count, right? And do something like this, move the current pointer to its next pointer. So after this step, now we have an h size of linked list, right? So what's the next step? Next step is we have to find kth node from the end. So as I told you, we can say uh, new k is equals to n minus k plus 1. And what does this mean? This means we have to find nkth node from the start, and that is equals to our kth node from the end. Right, so that's the idea. So now we have this position. What I'm gonna do, and yeah, let's initialize our current again from the head, right? And let's create one more dummy node, list node previous, which is obviously initially null. So we have this, if you see in the linked list, so I will point my head here, right, at 1, and previous is like just, you can imagine, it is just below, just before this one, and it is initially null, obviously, it's not going to point anywhere for now. And what we're gonna do is, while nk minus minus is greater than 0, we're gonna say, um, current, sorry, we're gonna say previous equals to current, and then current is equals to current next. So what will be the benefit? So if you see here, initially our head is here, right? And the total number of nodes are 1, 2, 3, 4, 5. 5 minus 2 is 3. So we have to find, 1 second, 1, 2, 3, 4, 5, and 5 minus 2 is 3. So 0, 1, 2, 3, right? So this is the node we wanted to delete, right? Uh, can we do anything else? I think this will be fine. So initially our nk, what will be my nk? It is 5 minus 2 plus 1, right? So it will be 4. Okay. So here it will be 4, then 3, then 2, and then 1, right? And we already have a previous, so I can just say previous dot next equals to current dot next. So I hope this is clear. So we can simply say previous dot next equals to current dot next. I think this is correct. So previous will be here, then previous dot next equals to current dot next. Yeah, and then we're gonna return the head. Just to make sure we are good with counting, let me print my previous. Okay, I have misspelled my previous. So let's call this previous. Let's print maybe like previous dot val plus a space and then current dot val. Now let's try running it. Okay, so here you see we are getting previous as a 4, which is wrong. We have to make sure this is okay. We are starting from zero counting, right? So we have to take 1. Now you see here, my previous is 3, right? My current is 4, and I just need to do 3 dot next is equals to 5, and this is what we are doing, right? So yeah, I think this is it. Let's see what will happen in case of some edge cases, right? So there will be one node minimum. So what happen if we have a one node only? So n is equals to 0, our head. So our n will come as a 1, nk will come as this, head will be this, okay, and then previous current is equals to next. I think this is fine. So let's try submitting it. No. For single node, I think it's breaking. Because my previous will be nothing, right? For a single node, my previous will be nothing. So that's why it's breaking. So what we can do now, we can simply say here, if n equals to 1, return null, because that is what we are going to delete, right? So now let's again try submitting it. No, what's the issue? Cannot assign next because it is null. Uh, so we have to delete like this node. So I think this is fine. Why this is breaking for two node? So one, two, let's see guys, why it's breaking. So it is saying cannot assign next because it is null. We are trying to access something from a null. What can be the reason? Okay, let me try debugging it. So for 1, 2, we're gonna have our nkh 2 minus 2 plus 1, right? So that will be 1. And let's try printing current to see why this is breaking. Uh, print ln current dot val, and maybe I can just copy this input and run it in my test case, something like this. Let's try running it. Yeah, because my current is getting null. Oh, no, no, no. I think std out is 1. But this is wrong. Why my std out is... Mm, this is fine. Okay, so current is not equals to null. We are doing n plus plus, so it will make n is equals to 1, and I will move current to the current next, and that is still not null. We come back, we do n plus plus, so our number of nodes will be 2. Now 2 minus 2 plus 1 is 1, right? And yeah, this is fine. So new k current equals to head. I don't know what's went wrong. Okay, we have a list node previous. I'm doing nk minus minus. Previous equals to current. Uh, Fair enough. And then current equals to current next. And then when I'm doing this current that well, I'm getting 1. So 2 is greater than. I think there should be at least one movement here. I don't know why this is not happening. Let me see. System dot out dot println. Hello. Simple debug. Let's see. Uh, are we going inside of this or not? We are not going. Why? So 2, of course, this is not 1 because, and then 2 minus 2, 0 plus 1, which is 1. So 1 is greater than 1. Okay, this is the problem. Yeah, if I do 0, now I'm going inside my hello. I'm getting the exact output. But then why this was breaking for this part? So let me see, guys. Let's try running in this case. This one is this one is this. Let's run it. Okay, now here you see it is wrong. Hello, 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 and then 5. So our current is 5. Our previous is this. Uh, is it due to odd or even numbers? One, 2, 3, 4, 5. Yeah, I think so. Maybe counting is making my logic faulty. Let's use something more cleaner. I think this is messy, and I mean it's hard to understand also. So I think this is clear. We have to now found the NKS node from the start. Let's initialize slow and fast pointer. Maybe I don't know. We can call it anything. Let's call it list node cur, which is equals to head, and then maybe next that it will be equals to head dot next, right? Now while um so here if you see our nk will be 5 minus 2 plus 1, which is 4, right? So 1, 2, 3, and then 4. So this is the element we wanted to delete. So we can do a for loop like this: I less than nk, I plus plus, and then I have to initialize my current equals to current next, and next is equals to next. Maybe I just need to this only. And now let's return head and see where is my pointers. Print ln cur dot val. I don't know why this is breaking for odd and even cases. This is fine. This is fine, but here, okay, let's create like previous. I think that will be more cleaner. I can say null and maybe previous equals to current, and then we can say something like, okay, we're gonna return the head. We're gonna say previous dot next equals to current equals to null. Question: if it is a null, then assign null. Else current next, something like this. Yeah, I think this was the condition we were missing earlier. Yeah, it's fine. Let's go to test case. Try with even number. And yeah, let's run it. Okay, now again I'm getting a null pointer because previous is null. Okay, I think if previous is not equals to null, do this. Else head is equals to head next. We can do this to handle that case only. So if it is the very first element, yeah, that's why I think it was getting null. But there must be some easier way to solve this. We are doing a lot of fixing here, right? In a linked list, let's try submitting it first and then we try to find out maybe a more cleaner way to do this. Yeah, we are able to solve, but I'm not happy with this code, honestly, because this doesn't look good, right? So what we can do? Uh, maybe if I let's say create a pointer, a slow maybe here and then fast at the three, and then I'm gonna move slow is equals to slow connect, fast is equals to fast connect, and that will be helpful. But I think let's move to the next question, guys. I mean, yeah, this is linked list kind of question. This will get messier, but yeah, at least we are able to solve, so we are good. Let's try to solve the third question. Okay. So answering the constraint, I generally see the constraint right away because it just gives me a general idea. So num dot length is 10, so hopefully it will be a recursive backtracking kind of problem, right? So given an array nums of unique element, return all the possible of subset, right? And the solutions must not contain duplicate subset and return the solution in any order. So if the numbers are unique, I don't think we're gonna have any duplicate subsets. Are we going to have? I don't think so. I think we can handle it. So, so if you don't know a subset, if you see by definition how you can create a subset of a array, it is something like this. You have, let's say we take only for two array, two size array. So how we can generate it? So the idea is either you can choose an element or not choose an element. Right. So that's the idea of subset. Subset means you try to take some element or not take some element and right. So that's the I think main idea. So for example here, either I can take the one or I don't. If I take one, so my answer will contain one, right? If I don't take, my answer will be empty. You can see like this. Then I go to the two. So either I can take two, so that will be one two, or I don't took two at all. So still it will be one. So one two and one. And for here, now we haven't choose anything. So either I can choose two or do not choose anything. So if I choose two, so two. If I don't choose anything, so this will be empty again. So you see here we have option like one, two, one, two, and empty array, right? The only thing I think maybe the question is it will be hard to understand how we are going to handle the duplicate because we are going to have some duplicate if I wrote the logic like this. For example, let's say for here, right? So I go to the one, I take the one, right? Then I go to the two, I take two. So one, two is my answer. Now, if I have a two, right? And if I don't choose, then again I can choose to one, right? So two one might there might be two one. So that will cause duplicates. So yeah, that will cause some issue. But let's see, we will be able to handle it maybe. Let's try first solve along with duplicates. Let's try to find out all the power set. So as we discussed earlier, now we're gonna have that logic of taking and not taking. So what we're gonna do now? I need okay list of integer answer we need to return. So let's create a instance variable list of integer to hold the answer. Uh, yeah, and then I'm gonna say my magic method that is going to do the all the magic for me. So I'm passing nums start with a zero, right? And then we also need to pass a temporary path. I mean the number of elements that we are choosing or not choosing. So that intermediate path we need to keep track of. For that, I'm gonna create an integer here. Okay, integer PSF I call generally call path so far something like this. New array list, and then I'm gonna pass my PSF here also. Right. So this did. Now let's write our magic method. Okay, my brain is not working. Okay, magic. Hmm. Nums. I will start, and this will be my PSF. I'm just coming from office, so that's why I'm feeling I'm a bit tired. So either you can choose the nums of I, or you are going to ignore it, right? So let's write the choose option. So if you choose it, then how we gonna have? So in if we choose it, so I'm gonna say PSF dot add nums of I, add that number in our path, right? And then call my magic method for others, I plus one, and then PSF. And then whenever we backtrack, we also need to make sure we are removing that number from our path so far, right? So this is very crucial in backtracking kind of problem. So whatever number I'm adding, I'm going to the next call. But whenever I'm returning from that call, I'm removing that number, right? And then option of not choose. So if I don't choose anything, we don't need to choose and we don't need to put anything in the PSF. We can simply say magic nums I plus 1. I'm not choosing anything and then PSF. Now here, if I equals to nums dot length, then means we have exhausted all our options. Now we have our answer in my PSF. So I'm gonna add that in my answer, right? So answer that add new array list. Make sure you to create new array list, right? Out of this PSF. Why? Because if you just add the reference of the PSF, like answer that add, just the PSF, that whenever we doing this backtrack, now all the arrays will be empty, right? So it will contain like nothing. So always make sure you are creating this a new array list out of this PSF, right? So after our magic method ends, I can just return the answer. So let's try submitting it to see. Do we have any compile time error or anything? Yes, we have. So I have misspelled my integer here. Let's see. Yeah, I think rest of this is fine. Okay, so here, and then we also need to return. Yeah, so here we are getting 1, 2, 3, 4, 5, 6, 7, 8, right? 2 to the power 3 will be the power set. So 8 we are getting. I think we can submit it. So it's a recursive backtracking based problem. So I think there should not be any issue. Let's submit it. Okay, so yeah, we are able to submit. So all my recordings, guys, it is random. I don't plan it. So the basic idea is I just go through my thoughts, right, on the question, and maybe hopefully try to solve it. So yeah, I hope you like it. So we solve. I think this power set is important question in the interview. It is being asked. Uh, if we see the question number two is also good question. On a linked list, I think removing, adding elements in a linked list, and then how you're gonna play with the pointers is important. So last time we solved LRU cache implementation, right? So and where we were using doubly linked list, right? So if you know how this move, how you're gonna count the number of elements in a linked list, how you can manipulate the pointers, then you are good in your programming language. In C++ and Go, it become messier because pointers, but in Java, I think it's pretty easy. Now, in question number one, I think this is very trivial. So yeah, I hope you like it. Let me know if you have any question. Thank you for watching. Bye, guys.